In that previous video, I showed you about how the book handles our recursive function using the f plus 1 on one side. We're not used to that as programmers, are we? We're used to having some type of decrementation in some fashion because we know it's going to end up failing eventually. So we are given if f of n plus 1 equals 2f of n plus 3, but that's actually going to be the same exact thing of just moving the plus 1 over to the other side. We have f of n equals 2 of f of n, set of parentheses there, minus 1 plus 3. This should make a little bit more sense to us as programmers on how that works out. And it works exactly the same as what we had before. Here's my call stack, here's my value stack, and I call it the return trip because everything's going to cancel each other out here. Now, by the way, it still has to find f of 1, 2, 3, and 4. How did I solve this? To be honest with you, what was my first call trying to solve this? It was actually f of 4. Why? Because I knew that we're going to be decrementing. That means we are going to have an f of 3, and I'm going to solve what f of 3 is. I knew we were going to have an f of 2, and I solved f of 2. So notice I did all of the work in one shot, where this is f of 1, that's going to equal 9. F of 2 equals 21, 45, and 93 respectively. That's why I did it, frankly, using starting at f of 4, is because, frankly, I knew it was going to do all the work for me because we know it was eventually going to decrement. What was the highest number in here? 4. It's going to take care of 3 and 2 and 1. So did I cheat? Not really. I just kind of studied what the function was going to be doing anyway. That's how we can take care of this using the stuff that, frankly, we should have gone over before in a previous class, but still want to go over it. I want you to go ahead and solve the next problem on the next page. So let me get to that real quick. Forgot about that part. So that's going to be this one. So I want you to go ahead and finish that one, and I am going to go over a solution with you on that one. I'll leave it at that. Get to work, and I'll see you in a moment. So let's go over our solution for this. You'll notice that I put the overall expectations back on top of my call and value stack here, just to remind myself really what the basic case is going to be very honest with you. So once I get to f of 0, I know flat out I don't have any more recursive calls, and I return a 2 no matter what. So if my first call is going to be f of 4, because frankly I'm asked to do f of 1, 2, 3, and 4, and I know this is going to decrement, I'm going to have that equal 3 times f of 3 minus 1. So obviously I'm not done yet because I can't solve what f of 3 is yet. So now we go to f of 3 equals 3 times f of 2 minus 1. And then we're going to go f of 2 minus 1, well, f of 2 I should say. And we have 3 times f of 1 minus 1. F of 1 is equal to 3 times f of 0 minus 1. And we know what f of 0 is, straight up 2. So now we can start solving for things, is that now I know where that f of 0 is now. I know is equal to 2. So we have 3 times 2 minus 1 equals 5. That's my solution for f of 1. I can replace the f of 1 that I was kind of waiting for here. That's 5. 3 times 5 minus 1 is 14. I have a solution for f of 2. F of 2 is now 14. We have 3 times 14 minus 1 is 41. And then, of course, as you can pretty much figure out by now, f of 4 is equal to 41. So 3 times 41 minus 1 is 122. Again, let me know if you have any problems with that particular problem, because that's going to creep up. It's not going to be like this type of system when you're doing programming or something like that. But again, I need you to think about your call and value stack in order to, frankly, help you establish and visualize what your algorithm needs to do code-wise.